All right. So use the link below to join the class so we can start. Okay. What do we have in the house? Please notify. Okay, lesbian, you're welcome. This who else is here? Please notify. Let me know who that is online. Okay, lesbian, you're welcome. Hold on, please. Let me get another marker. All right, which topic? Okay. Faith, Ude. Which topic do you say we are going to treat today? Faith sent so many topics that we are to look at now. So which one are we going to look at? Which one are we going to look at? Should we start from measurement? Because I want to be sure that any topic taught is being understood very well, perfectly. So that anywhere you see question on that, you'll be able to answer it. Okay, should we start from measurement? Okay, guys, what do you think? You start from measurement. Are we there? Sorry, the lesson started late today. I'm actually on night duty. I just came back, so but I have to teach the class. I don't want to reschedule it for another day. Okay. All right. Hope you can see the two lines on the board. Okay, so let me start from measurements. Now I have only one person on board out of 4. Let me start from measurement so that they will join later. All right. So say this is the physics. Say JAMB. Okay. So you're looking at measurement. Measurement of physical quantities. All right. We have to start from there. Important things you need to know that they might ask you as a question is physical quantities are divided into how many? They are divided into 2. Let me just do a summary. These fundamental quantities and derived quantities. Okay. Fundamental quantities and what? You are not seeing. Okay, let me adjust the board. Okay. Hold on, please. Let me balance it. It's being sleepy. All right. Can you see the board now? It's still far. Oh, so sorry. Okay. It's better now. All right. So let's proceed. Fundamental quantities and what? Derived quantities. Okay. So fundamental quantities, they are quantities that are what? That are independent. Fundamental are said to be independent. This is fundamental. So if I say independent, let me say fundamental quantities. They are what? Independent of other quantities. They are independent of other quantities. Rather, other quantities depend on them. Okay. So what JAMB asks you is this: which of the following are examples of fundamental quantities? Okay. So I'm going to read the examples of fundamental quantities so that you understand. All right. So the examples we have examples. We have the length. We have mass. We have time. We have electric current. Okay. We have temperature. We have luminous intensity. All of these are classified under fundamental quantities, right? They are classified under fundamental quantities. I hope you can see now. All right. They are classified under fundamental quantities. Now, we're going to be looking at the units. The unit of length is meters. Unit of mass is kilogram. Unit of time is seconds. Electric current unit is amperes. Temperature unit is what? Kelvin. And luminous intensity unit is what? Candela. So let me just state it differently so I can understand. You can screenshot, please. Or we can see the board now at Osakwe. All right. Is it cleared now? I seen the board now. Is it better now? Is it clear enough? At last VN, is it clear enough now? Should I proceed? It's too bad. Okay. Let me fix it. Let me see what I'm going to do now. Okay, please hold on. I'm trying to see a better way to do this one. Hold on, please. I'm having issues. Let me try to fix it before we proceed. All right, Atosakwe, is it better now? Atosakwe, is it better now?
I know this.
Is it okay now? Please, who is on that? Please indicate. Let's proceed. This one is better. Who is online? Please indicate. Let's proceed. Okay, I will. Thank you so much. Okay. Now, I've already started with measurements. Let me proceed again. Let me draw the line at the edges. You can see the line. Measurement. Measurement of physical quantities, right? Are we together? All right. So, physical quantities are divided into how many? Two. They are fundamentals and derived quantities. So let's go. I will say physical quantities are divided into two. One is what? Fundamental quantities. And two is what? Derived quantities, right? So this fundamental, they are said to be what? Independent of other quantities. They are independent of other quantities, whereas other quantities depend. You here is what are the or the following are fundamental quantities except, so you need to know the examples of fundamental quantities for you to be able to know the ones that are not included. So we'll say examples of fundamental quantities. So I have length, and unit is meters. I have time, unit is seconds. I have a mass, unit is what? Kg. I have temperature, unit is what? Kelvin. Electric current. Unit is what? Amperes. Right? Are we together? Do you understand? And Osakwe, do you understand? All right. So we have some other examples like amount of substance. Unit is what? Mole. So all these examples are classified under fundamental quantities. Okay? So we still need to know what are derived quantities. Do we understand? All right, let's proceed. Please, if you are just joining, you can screenshot what you just did. I'm just explaining fundamental quantities, okay? If you listed the syllabus, I want to start from the first to go down. Or if you still want me to teach any topic, I will do that, okay? So let's work together. The aim is for you to achieve a common goal, which is to score 90 and above in physics. Now, this class is supposed to hold Monday, Thursday, Friday, and Saturday, okay? 4 times in a week, all right? The class started late, supposed to start at exactly 9 o'clock, but because I have night duty and I don't want to cancel the class, I have to come late for the class. So sorry about that. But this week I'm on night duty, so my classes will not be from 9:20 or 9:30, depending as the case may be. But the most important is that we learned something to have. Yes, I've taught this before, but I do not know if those people on this group, whether they were with me when I started. Do you understand? So I want to, that's why I asked them if you have any topic in mind. That's why I threw this for them to respond. If you have any topic in mind, they should tell me. I know I've done this before when I started this January. Okay, so but if you join the class then and you still want me to teach it again, fine. If you still want me to teach something different, please let me know. Let me know, please, in a few minutes time. If not, I will conclude with the topic. I'll talk about the derived quantities and I'll go to dimension of physical quantities. Then we'll conclude the topic for today. Are we together, guys? I want to have your response. At Osakwe, who else is online, please? Is it Faye? Respond, please. Let me know. Okay, celebrity, you're welcome. All right. All right, celebrity, were you with me when I did this topic on the board before now? Did it? I should continue. All right. So as celebrity, if there's any topic you want me to treat, you can tell me. So when next I'll meet, I'm going to do that. Okay, so you're not with us. Okay, so I'm on point. I will just continue with the explanation. Okay, so you can understand. This is the first topic in physics. At least you should expect 1 or 2 questions from here, right? So what we're talking about is measurement of physical quantities. Physical quantities are divided into how many? 2. You have fundamentals and what? Derived quantities. And I said that fundamental quantities are what? Quantities that are independent. Independent in the sense that they don't depend on any quantities. Okay, so but what JAMB will ask you is this: which of the following quantities are fundamental quantities, right? So they will not need to tell you to define what fundamental quantities are. No, they will not. So I listed the examples of fundamental quantities and their units. I have what? I have the length, measured in meters. I have time, measured in seconds. I have mass, measured in kilogram. I have temperature, measured in Kelvin. I have electric current, measured in amperes. Amount of substance, measured in what? Mole. Do you understand? So they may ask you, which of the following units are fundamental? The following are fundamental units. So these are the units. Each of the following are fundamental quantities. These are the quantities. Are we cleared? Now, out of this, I have like 6 or 7. I didn't add the luminous intensity. Okay, out of this, the only one, or the ones that are more important out of this, it's supposed to have 7, have luminous intensity. I made it 7. Okay, the unit is what? Candela. All right, so out of these 7, these 3 are more important than the rest. Have the length, time, and what? Mass. Why are they important? Because we need them to get what? The dimensions of physical quantities, right? They are important because we use it to get the dimensions of physical quantities. I hope you are cleared. You still have questions before I proceed? All right. Any questions so far? Someone else joined us. Please indicate what's your name, please. Let's know who is online. All right. So let's go to derived quantities. Derived quantities. Like I said, as fundamental, they are independent. So in derived, they what? Derived, they depend on other quantities to survive. Okay? Fundamental quantities, or we can say that derived quantities are the quantities that is being obtained by the combination of 2 or more fundamental quantities. Okay? Are obtained by the combination of 2 or more quantities. Okay, so when we add these 2 fundamental quantities together, we're going to get one derived. All right, so their units are equally called derived units. Let's look at the examples. We have what? Quantities and their units. I have number 1, area. Area is what? Meter square. I have volume. Volume is meter cube. I have speed. Speed and velocity, they are the same. I have meter per second. I have acceleration. I have meters per second square. I have force. That is kilogram meters per second square. Now, these 5 are the basic units or quantities in derived quantities. Reason being that okay, Faith, you're welcome. All right, reason being that it will help us to derive other quantities, right? It will help us to get more quantities. The unit of area is meter square, unit of volume is meter cube, speed and velocity, they are the same. The only difference is this: one is scalar and the other one is what? Vector. So speed is scalar and velocity is what? Vector. Acceleration is meter per second square, then force is kilogram meter per second square. I don't know if you understand what I just explained. All right. If you do understand what I just explained, I'm going to go into other derived quantities and also go into dimension of physical quantities. Are we cleared? Do you have questions? All right, in the absence of no question, guys, let's proceed. Let's go to other derived quantities as well as their what? Their derivation. Okay, so let's go. All right, I still have I think number 6, if I'm not mistaken. Um, moment. Moment is what? Force times distance, okay? But most times you can still use your hand and generate your own unit, right? So force is given as kilogram meters per second square times what? Distance is meters, okay? This one has power of 1, which gave rise to kilogram meters square per second square. That is moment, okay? Now, we also have a and force is the same. So let me just put slash, sorry, moment and work slash work, they have the same unit, slash energy. So you don't get confused. You may ask you which of the following has the same SI unit. You have moment, you have work, you have what? Energy. You have the three have the same unit, right? So it can go. Now we have number 7. I have momentum. Momentum, that is mass times velocity. Okay, my mass is measured in kilogram, velocity is meters per what? Second, right? That gave rise to kilogram meters per second. Are we together? Guys, are we together? You have question? Any question, guys? All right, so let's proceed. So I want this to be an interactive class, okay? Okay, so the next one I have pressure. I have 8. Pressure is force over area, right? What's the force? That is kilogram meter per second square over meter square. Take this one up, it becomes kilogram meter per second square times what? Per meter square. That gave rise to kilogram minus 1 per second square. So that's the unit of pressure. Do you understand? And pressure and stress. Pressure and stress. They have no SI what? Unit. Pressure and stress have the same SI unit because they are defined the same way. Stress is defined as the force per unit area. The same thing with what? Pressure. So they have the same SI unit in case you're asked. So number 9, let's look at density. Number 9 is density. Density is mass over volume. Density is mass over volume, right? Now, what's the mass? Mass is kilogram and volume is meter cube. Okay. Now take this guy up. Remember, it's in the denominator. It's going to carry a negative sign. That becomes kilograms per meter cube. Right? So this is how you can get the dimension of most derived quantities. So the most important thing you need to know is you should know the main derived quantities, which will help you to get the other ones. For example, we have the volume, the area, we have the speed and acceleration, and we have the force. Quantities are very, very important that you should master them because you use them to merge with other quantities to get their main unit. Are we clear? Please ask your question if you have. Ask your question, guys. All right, so let's proceed. So let's go to dimension of physical quantities, okay? Dimension of physical quantities. Okay, so I thought that the three main fundamental quantities are what? The length, the mass, and what? The time. Now, this is the length. This is the mass. And this is the time, okay? So unit of length is what? Meters. Denoted by small letter m. Unit of mass is kilogram. Denoted by kg. Unit of time is second, denoted by what? X. Now that is the unit, okay? For us to write the dimension of this quantity, we are going to use what? The first letter, which is L. So here the dimension is what? L, right? Here the first letter is what? M. You just put M. This one is what? T. Just put what? T. So the dimension of length, mass, and time is what? L, M, T. Do you understand? So that is the first thing you are going to note before I can get the dimension of other quantities. For example, let me say this is derived quantities, and this is what? Dimension. Now I can start with the first one, which is what? Area. Unit of area is meter square. All right. Well, anywhere I see meter, I'm going to write what? L. So this is L what? Square. All right. We have volume. Unit is what? Meter cube. So I have what? L cube. Okay. So speed and velocity. Speed slash velocity. I have what? Meter per second, right? So this becomes LT power minus 1. Are we together? I have two people watching. I don't know. I have two people watching. I the only one here. Please, who else is with us? Please indicate if you are here. Let's know. Faith, are you still here? Okay, there. So let's proceed. Celebrity solutions. Let's proceed. Hope you understand what you are doing. Are we clear? As celebrity. Are you guys see your Pro 50, guys? Because any topic that is being treated, you are going to solve all the questions there. All right? To solve all the questions so that we can proceed from there. Okay, so the next one is, let me look at few past questions when I'm done with what I'm doing now. Few past questions so that the rest of the questions, so you can attempt it and give me your feedback if you have any question. Okay, so I have acceleration. Unit is meter per second square. So that becomes what? LT power minus 2, right? So the last one is force. Force is what? Kilogram meters per second square. That becomes what? This is M. That is M L T power minus 2. Are we cleared? Do you understand? All right. So what we're going to be doing here is we're going to be looking at SS2, I'm sorry, SS1, SS2, SS3. Okay, questions and topics to be explained before we answer questions. Now, any topic that we are done explaining, you are expected to go back with your pre 50, look at all the JAMB questions there and attempt them, okay? Send back to me anyone you feel that you could not be able to attend or you do not understand. Is that clear? So this will make us to go around all the topics and be able to cover it in limited time. Your pre 50. Okay. So let's proceed. Let me look at a few JAMB questions under this topic now. The question says, which of the following is not a fundamental SI unit? A is meter, B is what? Amperes, C is Kelvin, D is radian. Now look at all the units of fundamental quantities that I gave you. Which particular option do you think that is not a fundamental unit? Okay, which particular one do you think that is not a fundamental unit? So tell me your answer. Also, tell me your answer. Okay. Where is the answer, please? D. Okay. Celebrity solutions. What's the answer? Celebrity solutions. What's your answer, please? So I want the class to be interactive, okay? Because that is the main aim that we are here. Let's achieve it. The answer is what? D. Because looking at what we have done so far, radian is a unit for what? Angle. And angle is not a fundamental quantity. So that is the only one among the options that is not a fundamental quantity. So the correct answer to this question is option D. Okay? So now number 2. Let me say, which of the following quantities has the same unit as the what? Okay, so they give us A to be force times time. B to be force times distance. C is force times acceleration. And D is force times velocity. All right. Coming to this question, we can look at it closely. You now understand what the question says. It says, which of the following quantities has the same unit as the watt? Now, what is watt? That's the first thing that will come to your mind. What is watt? Watt is a unit measurement of power. Power is measured in watts, right? So that means I asked to define power and also look at the formula that you can use to solve for power. That is clear. So we're going to look at power entirely. Then we now look at how we can solve problems with it and know the particular option that will fit in. So power is work done over time. Okay, power is work done over time. And we ask what is work done. Work done is force times what? Distance over time, right? Okay. Now, distance over time is equals to velocity. So the whole of this is equals to what? Velocity. That is, this is force times what? Velocity. Okay. So that makes this to have the correct answer as what? D. Now, I did not bother to start solving it separately to know the one that will fit in because of limited time given in each question. What I did was to just look at the watt as a quantity. What is the unit of this particular thing that is in watt? Get that quantity and do what? And solve it out to see the one that will give you the correct answer. Are we cleared? Do you understand? Do you understand? Guys, do we understand? Please, I need your feedback. Are you together, please? Please, I need your feedback, okay? Please drop a comment. Let me know what's happening. All right. So we still have questions. Anyone who could not attend within this 1 hour class are going to solve them, okay, on your own. I'm going to send some as a question on the group. So you answer them and send your answers. If anyone you could not understand, please you let me know. That is why I'm here. All right. So the next question. The next question says, that be question 3. Which of the following is the dimension of pressure? A is what? ml power 1, t power what? ml power minus 1, t power minus 2. B is what? ml t power minus 2. C says ml square t power minus 3, and this says, okay. So now look at this question. You're going to see that if you're able to get the dimension of pressure, that's the first thing. The first step is to define this pressure. And if we should define this pressure, we should be able to get the dimension of this pressure. Then we now look at the options, the one that best fits into what we have calculated. Now you should know the definition of pressure, that is force over area. So in an exam setting, you should be able to know what is pressure, force over area. Okay, you have already known what is what force, kilogram meters per second square. So it will help you to remember it and solve it within seconds. So pressure, I'm saying you don't need to memorize the formula for pressure, so you can work it out on your own. Is force over area. Okay, so what's my force? My force is what? Remember, it's kilogram meters per second square. So this is kilogram meters per second square all over what? Meter square. Are we there? Now what I'm going to do is to carry what? This meter square to the numerator to have a negative sign. So that is kilogram meters per second square times per meter square. I want to break it down the way you understand. So this is also equals to kilogram meters 1 minus 2, because this will have an invisible power of 1, then x minus what? 2, which gave rise to kilogram meters minus 1 x what? Minus 2. Now this is just the unit. Some people used to solve it dimensionally straight, but for you not to get confused, I prefer solving it this way. Then when you are done, you can convert it dimension. Okay, now we are done solving. It is what? Kilogram per meter per second square. Now for the dimension, the mass is given in m, why the length is given is what? That is meter, given in what? L power minus 1, then t power minus 2. Do you understand? All right, so looking at this now, the correct one that can fit in or that suits what we calculated is option what? A. Do you understand? So I want you to see the procedure that it took me to be able to get the dimension of that quantity. Are we clear? Any question? Any question? Okay, you're cleared. Okay. What of celebrity? Are you cleared? Celebrity, are you cleared? Do you have question? All right. So, celebrity, do you have your pre 50 with you? Have you gotten your pre 50 physics? So, one more question to go, okay? So we can proceed. Okay, so you have, okay? So the rest of the questions after today's class are going to solve them and give me your feedback, okay? That's for units and measurements. So if anyone do not understand, you let me know. Is it clear? Anyone you want me to solve for you, please send me on WhatsApp. I will do just that when I'm free. Okay? All right. Remember our lesson days, we have Monday, Thursday, Friday, Saturday. I hope I'm not mistaken. These are lesson days, okay? I am starting by 9 p.m. daily. Okay? But today I have a night duty and I came in by 9. So that I couldn't start exactly 9 p.m. But by Thursday, I come by 9, I can start immediately at 9 p.m. So before we go, we have few questions to solve again. Let's see. All right. Okay, this question says respective value of x, y, and z would the unit of force, the Newton, be dimensionally equivalent to ms ly tz. Okay, now look at the question. It said, at what respective values of x, y, and z would the unit of force in Newton be what? Dimensionally equivalent to mx, ly, and t power what? Z. Okay, now what we're going to do now is to do what? Is to look at force first. Let's get force. So what is force? Mass times acceleration, right? Now force is mass times acceleration. Okay, my mass is kilogram, my acceleration is meter per second square, right? Then multiply them together, you have what? Kilogram meters per second square, right? We are comparing to this, that is dimensionally. So let's get the dimension of this one. The dimension is ml t power minus 2. Okay, then comparing it with this, which is also equals to m power x ly t power what? Z. Is that clear? So we equate them by saying that m has a power of 1 is equals to m has a power of what? X. Cancel. Therefore x is equals to what? 1. Are we clear? But because if you have done it before, you don't even need to know these steps. You're going to waste your time when you have short period of time to write your exam. So what I'm going to do is look what is on top of this m. Nothing. So it has what? 1. Because if it is 0, 0 means nothing. So now this one has x. So m power 1 and m power x is cancelled, right? X is equals to what? 1. Then coming to this one, I have the same thing. It has infinite power of what? 1. Okay, so L power 1 and L power minus 1, which one is greater? All right, so what we're going to do is to cancel it out, okay? And we say that y is equals what? Is equals what? Minus what? Sorry, this is y. Y is equals to 1, okay? Then the same method, z is equals to minus what? 2. So I've gotten the values as what? As x as 1, y as 1, and z as what? Minus 2, right? Now this is how to solve this type of question, and what you need to do is to first of all get the dimension of what you are requested to do. After getting the dimension, what you are going to do is, I prefer you finding the unit first so you don't get confused until you master the tricks. Okay, when you get the unit first, so the next thing you're going to do is to do what? Is to get their dimension, blend them together, add where necessary, and so you don't make what? Mistake. Okay, because that power is very, very important. Yes, we are 5 in number and we have just 2 people here. I hope they won't take us well because we don't have much time again. Our time is ticking, so we have to proceed. Okay, we have to proceed so we can meet up. We have just this month and next month to cover up. Then any other topic remaining, we have to do it the revision. So we have to proceed as much as we can. So that is why anywhere we stop with the past questions, so everybody will go there and solve their own and bring that feedback to meet again. Okay. All right, guys, do you have question with that? You don't have problem with that? No problem. At Lesbian at Osakwe as celebrity. So go to your prep 50. You have some other questions there that we have not attended. Please work on them and give me your feedback. Okay? Give me your feedback, okay? You can send it on WhatsApp. Let me see. At Osakwe, you don't have your prep 50. So try and get one, okay? So that you can be able to follow us. I want everybody to have their own prep 50 because that book is good. I use that one for my student, and I also use another one. There's a book I use for speed and accuracy, but I use prep 50 to analyze different topics for students. Okay. There's also another book I use for speed and accuracy. Before you visit your CBT computer, you should be able to know some how do I put it? You should be able to cover a lot so that you don't see 5/4, you now be discouraged. Okay. So, but there's another book you're going to use to checkmate your speed and accuracy. That one is not, I will show you, maybe I'll snap it and send it on the group. That's not Prep 50. Prep 50 is for topic by topic, but this one is like a real JAMB question, the way it is for different years. Okay. So my students are supposed to answer those years repeatedly, then come out with their what question. That is how it is. Anything that they do not understand at this point, they should let me know. Okay. All right. So do you have question? If there's no question, I'm going to end the class now. So please do the rest of the exercises or the rest of the questions there, and let me have your feedback in the group. Are we clear? All right, guys. We're going to start here to continue on Thursday within the week. All right. So I'll be expecting your questions on the group. Okay. All right. You're welcome there. I'm expecting your questions on the group. Please don't forget to do what as I instructed. Go through it today. Don't forget, because tomorrow is, I'm going to give you what you're going to do for tomorrow. So the days I'm not going to be having classes with you, what I'm going to do is to bring out questions I'm going to solve to keep you busy. Because from now to April, from now to the end of March, that's what we have. April is back to back until you write your exams. Okay. All right. So I will see you later on the group. Bye for now.